Hey, g'day, it's Prezzo here. I'm doing some casting today, and this is the Mark II version of the DIY blast gun that I did some time ago. And if you want to go back and look at the original video of that, I'll put a card up and you can check that out. When I made the original, it worked and it was successful, but I think I can do a better job this time around. So I've modified the pattern to include a little bit more material here where the threaded cap goes to hold the nozzles in place. And you're probably looking at this little detail here and saying, well, that's just decoration. And it's not. It's EGT, or Enhanced Grip Technology. And that's going to make all the difference. I feel sure it's going to be a much better blast gun because of that detail. And the way I did that was I just cut out some sort of like heavy duty cardboard, and I stuck that on with some CA glue just to make it dense, and then I've filled that and painted it. So that's the pattern. This is the new version of the core. Whoops, where are we? There we go. This is the new version of the core, and this is an epoxy resin and sand core. And one of the problems I had in the last build was the material didn't fully run around that core. And I've got a couple of tricks up my sleeve to make that work. So let me get this ready, and then I'll just show you what I mean. Okay, well, this is what I got so far. This is half of the pattern for the blast gun. This is another unrelated casting I'm doing for a different job, which you may or may not have seen. I'm not sure yet. So just ignore that one for the moment. So my sprue is a tapered sprue. It goes down and meets up with the gate here. And this is where the riser will be over here. And the metal is going to flow through, and it has to flow around the core, which is going to go into the core prints. Now, the last time I did this, I didn't vent the core. So this time, what I've done is I've run a wire down through the core before it cured in the mold. So there is basically a hollow space that goes down through each one of these three extensions here. And that is to allow excess gas to escape from the core. But you've got to have somewhere for that gas to go when it gets into the mold itself. So what I'm going to do differently this time is I'm going to provide an escape channel for that gas. So I'm going to just simply scoop out a little bit of a hollow at the end of the core print. And I'll do that for all three of them. And this is the drag that I'm showing you here at the moment. I'm going to do the same in the cope. Doesn't need to be a lot, just enough for the gas to accumulate in that little pocket and then escape through a vent. Okay, so that takes care of that. And because this is the drag, this is the bottom of the mold, the vent needs to come up through the cope. So I've still got to do that. I'll get this out of here, get these both out, tidy this up, and then we'll have a look at the cope. Okay, so this is the cope of the mold, and I'm just going to do the same here, just sort of scoop a bit of that sand out. And then we'll run a wire to the top of the cope. So this wire is just an old bicycle spoke. Okay. Alright, so here we are with the drag again, and I can put the core into its core prints. And this is where you got to just take a deep breath. It's all good. So now you can see at the end here where the hole in the core is, it will vent out into this little open cavity here and up through the hole that I made in the cope. That's the theory anyway. And you see how little material I've got around this section of the core here, and this is to form the cavity on the inside of the blast gun. Now the last time I did this, that part of it worked well. The core did its job really, really well. I'm sort of expecting the same this time, but I'm hoping that by venting that, we're not going to get like a gas bubble, which is going to prevent the metal from flowing around that cavity. So let's get this together and get some hot metal in it and see what happens. Okay, I did mention I was going to do a couple of things to improve my chance of success this time around with this thing. And the second innovation that I want to show you is to be using a pyrometer. And this is it here. Now I bought this probe from eBay. It's called an EGT, or an exhaust gas temperature probe. It's good up to 1000 degrees centigrade, which is more than enough for melting aluminium. And I've just simply mounted that to a stainless steel bracket, and it's pop riveted onto a piece of 12mm aluminium tube, which I bent just to make it easy to get it into the crucible. The shielded wire from the probe, which has got a stainless steel braided cover and it has fiberglass insulation on the wires inside, that goes into a hole bored in the tube and comes out the other end where it's attached to my multimeter. Now this meter has a temperature function on it, and unfortunately I don't have the correct plug for my probe, so I'm just doing a bit of a lash up here just to see if it works. I 3D printed this case for the meter, and it's got a pair of clamps here that clamp down to the tube, and the wires for the EGT just come out the end of the tubing and loop round up to the meter. So my temperature, I've got this marked on here at 650 to 700 degrees C, is what I researched as the best pouring temperature for material that we're using, although I've heard of some people going lower than that. But what I want to avoid this time around is get a situation where the metal cools before it fully fills the mold. So I just want to make sure that we've got the best chance of getting this to work. Anyway, I'm going to get lit up and we'll get going. Now that's over. So this mold here is my blast gun, and I did a second casting at the same time with a common sprue and pouring basin. That seemed to fill up quite well, so yeah, I'm feeling confident. But you never know till you break these things open, and that's the pity of it. When things go wrong, you got no idea, and you just invested 5 hours in getting all this ready. Anyway, we'll check it out shortly. Well, it's always a bittersweet moment when you open these. Alright, I think we've had a win. So there's the blast gun, no voids anywhere around the outside of that. The core's done its job, as you can see, made the hole right through. There's my U-Butte lightning bolt detail that's come out perfectly. So that is a success. Now this other one, that's for my bandsaw, my metal cutting bandsaw, and that was meant to have a core in it. I tried doing it with the core and I wasn't happy with it, so I've just done one as a solid casting, and I'll machine out the areas where the core was meant to be. But that is looking fantastic. I'm happy with that. So I'll get on now and I'll build the rest of the gun and I'll show you. Just a little side note. Remember I put the vent through? Now, just by pure bad luck, that's where the vent came out through the top of the cope and it went right into the pouring basin. So that was sort of bad planning on my part. But it looks like the metal's flowed down from the top rather than coming up from the bottom. In fact, there shouldn't have been any passageway to the molten metal for that vent. That was meant to be a pathway for the gas to escape. But either way, it's worked. So that's great. Okay, there it is, all finished, and I tested it and it does work, and it is an improvement on the original gun that came with my blasting cabinet. Just to talk you through the finishing process, this was all sanded back. The casting was sanded over with wet and dry paper. I ground as much of the texture off the casting as I could, and this has been powder coated in a candy red sparkle, which gives it that lovely sparkly finish. And I then rub back the detail on the lightning bolt to expose the aluminium, and then the whole thing is clear coated again. The jet carrier or the jet nozzle assembly has been zinc plated. I'll show you that in a minute. I've used the original stainless steel coupling for the plastic tubing, which brings the grit up to the gun. And this is the original cap and nozzle that came from the original gun. Now, what can I say? the lightning bolt and this little ring at the back here, that's just pure whimsy. I mean, that's just decoration. No practical purpose whatsoever. The only other change I made to the gun, I drilled out this little hole here. This was originally, I think, to hang this inside the blast cabinet. I don't think that that's necessary. I'll show you what I've done with the jet, and this has made it a little bit easier to control the size of the opening. So this is mild steel now. I did consider making this out of some sort of hardenable steel, but at the end of the day I don't think it's necessary. This has been zinc plated and put in a gold dip, which gives it that colour. It's very soft, and just sliding in and out of that casting a few times, it scratched that coating off, but it's just corrosion protection more than anything else. Now I've got a brass replaceable tip in there, and you can remove those with a socket, and you can do it from the outside of the gun. You don't actually need to remove this assembly to do this. So I made a couple of these in different jet sizes. I think this is a 2.25mm jet. I've done a 2mm, but from the previous test I did, I think 2.25 is about right. It gives you a good vacuum and a good blast for the media, but doesn't consume too much air. So that's all good, and that goes back in and can be locked in place with a pair of socket-headed grub screws. And I've got a mark on there, and I've already tested this to work out the optimum position for that jet. So we can lock those two grub screws in place there, not too hard because it'll bite into the steel otherwise. I've already got my quick coupling on here. When this goes inside the blast cabinet, it'll be replaced with one of these. So what I want to do now is just explain the differences between this gun and the original Mark I casting that I did. So that's the first casting with the cavity inside it cast with a core. This one here I've used a different style of core. So let's just have a quick look at that. This is a section of both the Mark I gun and the Mark II gun. Externally they look exactly the same. The difference is all internal. So on the original Mark I gun, the tube which brings the media up to the mixing chamber was just a straight connection. There was no attempt to radius off that or blend in that opening to the main cavity, and the corners of that cavity were dead square. So a lot of people had commented and said it wasn't very streamlined, it would slow down the mixing of the blast media with the air, and it would lead to erosion on this corner here. So on the Mark II gun I restyled all that interior cavity. So you can see now that I've blended that corner and this front corner here with the radius, so that as the blast media comes up and mixes with the air, it's not drawn over that sharp corner anymore. I've also tapered the front of the chamber to match up with the taper on the nozzle. I've done the same at the rear, although that was more about just, sort of reducing the amount of thickness of metal at that end of the casting. So this business end here is where we're going to get the blast media coming up. It sort of meets in this chamber here, and I think, and my understanding is that this chamber is acting like sort of a buffer. So when the blast media comes up, it comes up in sort of like bunches. It comes up as sort of large dollops of blast media, which I think are accumulating in this chamber and then acting like a buffer. So as the air jet accelerates the blast media out through the nozzle here, we've got a continuous supply, even though the blast media is coming up in a non-continuous fashion. Now, I sort of thought that if I can get this like a convergent jet, and then we accelerate the air through that convergent jet, that it would create more vacuum. Now, the surprising thing is that it doesn't. I've checked the old gun and the new one, and there's almost no difference in the vacuum, which I thought was surprising. I was sort of expecting and hoping that we were going to get a much better suction. Now, having said that, it does what I want it to do. I'm not unhappy about the way this new gun performs, and I'll show you in a minute how we can test that. So that's the internal difference in the shape, and like I say, the rest of it is just pure decoration and just making it look pretty, really. And I believe that if George Jetson was into sandblasting, this is the blast gun that he would use. Absolutely. Okay, so how do we test this? Now, in one of my previous videos I showed you a manometer, which was a device for testing vacuum and suction, and I completely forgot and I actually had this vacuum gauge, and I dug it out. It's on a vacuum pump that I use for doing some veneer work, and I've just made up a brass fitting here so I can connect it directly to the suction line of the blast gun. So with it set up like that, we can connect the blast gun to some air using like a realistic pressure of about 80 psi, and we can read the vacuum directly on the gauge. So what I'm going to do first, we'll set up the old gun, the original one, and we'll do that test and we'll have a look at what result we get, and then we'll check out the new one. Okay, well here's the setup I'm using. So I've got the gun connected directly to the air line. I've got my regulator set to 70 psi. I've got my gauge here which reads in inches of mercury. Now I just checked, and 1 inch of mercury is equal to about 3.386 kilopascals. And all we want to do here is get like a comparison, so I'm not too worried about what the units are. So let's connect this up to the air and just see what happens. Okay, I read that at 14 inches of mercury. So we're going to swap over now. We'll put exactly the same setup on the new gun. Alright, now I've got no air valve on this one, so as soon as I connect the air line we're going to get a reading. So we'll try that. Alright, so I read that at 16 inches of mercury. So we've gone from, what's that, 14 to 16, which doesn't seem like a huge difference. But the important thing is that the size of the jet that I'm using here is 2.25. Size of the jet in this one is more like about 3.5, maybe 4. And this uses a huge amount of air. My compressor just can't keep up. With this one here, I'm getting more vacuum, but using less in terms of volume of air. So, I don't know, that's a win as far as I'm concerned. I'll just show you that you can get at that little brass jet. So you can see it inside there, and I can just put a socket down in there and remove that, swap out the jets if I need to. So if these brass ones ever wear out, you know, I've got a way of just easily removing and replacing those. Okay, I just worked it out, and I'm getting about a 14% improvement in vacuum with this gun. And when I did my initial tests using the manometer, using very low pressure, I was getting an increase of about 45%. Now I knew that those results I was getting were skewed because of the very low pressure. It seems like as we come up to a higher pressure, the vacuum properties of the guns are getting closer together. Now at the same time, I'm not too worried about that. The more important test is, you know, does it deliver the blast media at a higher velocity, or do we get more volume? And to do that, I need to set up another test. Now I'm not going to cover that in this video. I'm going to revisit this later on. What I've done is I've ordered some clear acrylic tubing, and I want to be able to make a replica of this gun with a clear body, and then we can visualize what's happening to the grit as it's being sucked up into that chamber, and we can find out whether it is actually storing it and then shooting it out through the nozzle, or whether it's just sort of being consumed as soon as it arrives in that chamber. But until we get a see-through blast gun, we're not going to be able to tell. Now at that same time, I'm going to do another test inside the blast cabinet itself. I'm going to see how much grit this can deliver at a set pressure compared to this gun here. And then that is probably the best real world test we can do on this. But for the time being, I'm just happy that it's shiny and red and it's got lightning bolts. So for me, that's a win. Anyway, check in on a few videos time. We're going to have a look at that clear blast gun and see how that behaves. And I've got another project coming up, which is a wood to metal cutting bandsaw conversion, which is looking quite promising. So you'll be able to see that in the next, maybe another couple of days. But until then, thanks for watching. I'll check you on the next video.